I have had this doubt for a long time that despite the extremely small sizes of particles, how do scientists and physicists measure them? So, what you're asking is, let's say you have an atom or a nucleus of an atom, basically subatomic particles. So, how do we know the sizes of these subatomic particles? So, this is a question that's similar to the rate of rotation of galaxies, but it's at the opposite end of that, of the scale. Galaxies are immensely large, subatomic particles are immensely small. And yet we know that the nucleus of an atom has a certain size. We know that other subatomic particles have a certain size. How do we know that? That's an excellent question. Did your teachers ever answer this? I doubt it very much. Right. So here's how it's done. Let's say you want to measure the size of the nucleus of an aluminum atom. So what you do is you take a thin sheet of aluminum, aluminum foil, right? You try and make it as thin as possible, and that is your target. And then you create a vacuum apparatus. You place the aluminum sheet as the target, and you shoot a beam of electrons. Let's say electrons. You can shoot anything, but let's say you shoot a beam of electrons at this target, and you set up detectors behind the target and at various angles around the target, and you see how many electrons are scattered in what direction. So we know that atoms are mostly empty space. It's a nucleus and you have electrons around that, and most of it is empty space. So most of the electrons that you shoot at the aluminum atoms, they're just going to pass through the aluminum foil, right? They're just going to pass through them. And yet some electrons are going to get deflected from the nucleus at various angles. And in extremely rare cases, you will find that electrons will hit a nucleus head on and bounce back in the opposite direction. So that also is to be measured. So then you determine how many electrons were fired. Okay, you can measure that, and you can detect how many hits you were able to measure behind the target or at various angles around the target and on the opposite end of the target. And based on these calculations, how many measurements you were able to make at what angles, you can determine the size of the nucleus. So it involves a bit of trigonometry, geometry, algebra, all that, but the theory is pretty simple. So that's how it is done. So basically, let's say you shoot 1 million electrons at a single atom of aluminum, and let's say out of those 1 million electrons, 99.3% just fly away, and they just pass through the atom, but a small percentage will be deflected right back. So that percentage tells you what percentage of the atom is actually the nucleus. So we know that the nucleus is very small, and then based on other calculations, you can determine exactly, or not exactly, but to a good fidelity, how large the atom is and what is the probability of error in that. What is the error calculation in that? So that is essentially how we calculate or we measure the actual sizes of atoms and nuclei. So you can do this with aluminum, we can do it with gold, we can do it with calcium, and eventually you can even do it with hydrogen and all that, right? So that is how it's done, and this is a process that takes long time. In the very beginning, it was thought that atoms are essentially like plum puddings. You have a smeared out charge in them, and later it was discovered that they actually have a nucleus because they did this very same experiment, and they found that a very small percentage of electrons actually bounce back, and that's how it was discovered that atoms have nuclei. And then this experiment was refined and done over time for over the various decades, and that's how today, because of the improvements in the experimental apparatuses and all that, today we have a very good idea of the size of various subatomic particles. So that is how it's done. This is all about experimental physics.